We are going to achieve so much in this video. We'll set up and test a fully automated auto refill operation on our Sovol SV08 Max using 3 BIQU Panda feeders this time, powered cleanly from the printer's own CAN bus cable. We even insulated the printer to handle high temp gerGO ASA, rolling it right near the window this time for proper venting. Plus, we fine-tuned the load and unload macros to the absolute best of my ability, but don't worry, I will not disappoint. I will be making mistakes at each and every step, so you won't have to. I'm gerGO, and welcome to gerGO Print 3D, our YouTube channel, where my nephew Levi and I share our adventures with Sovol and other 3D printers, lasers of all shapes and sizes, and now even CNC machines and other fun DIY gadgets. Just like all our videos, this one has curated translation-ready subtitles, chapter markers, and multiple audio tracks to give you the best experience possible. We just got word from Sovol. Our M1D is on its way. We will be able to show you unboxing, setup, and how it works. Exciting times. But we'll stay busy in the 10 or so days while we wait for it. We just received 2 more BIQU Panda bamboo feeders, for example. Quick disclosure, BIQU kindly sent these over for us to test. But as always, all opinions and mistakes are my own. If you want to grab your own auto refill fleet, please use our affiliate links below to get the best price while supporting our channel. Now with these, we are finally ready to set up the ultimate auto refill operation. But first, let's catch up on a little project from last time. In our previous video, I asked if anyone knew the exact name of the printer's unused CAN bus plug. A massive shout out to Sam Schultz, Tommaso Blanchi, and Dr. Emmett Brown for hitting the comments and correctly identifying it as a Microfit 3.0. You guys rock! And it's exactly why I love our comment section. Armed with that info, I grabbed the Microfit 3.0 connector kit and the 90-degree elbow DC 5.5 by 2.1 mm barrel connector from AliExpress. For the pinout, just connect the top right pin to the center and the top left to the outside of the barrel plug. This completely eliminates the need to plug in that bulky external power supply. Just like last time, I tested the setup on the sofa first, and this single CAN bus line seems to have enough amperage to drive not just one, but all 3 of the Pandas. We'll definitely see if this power supply remains stable enough during long prints. By the way, jump into those comments and let me know, would you trust your printer to infinitely feed itself while you sleep, or does it make you nervous? Before we mount these, a quick shout out to our sponsor, Justway. You might remember the custom side panel we designed for Levi's Melgeek Mate 68 V2 gaming keyboard, which we printed ourselves. Well, using our exclusive $10 coupon, you could get similar custom parts professionally printed or CNC machined out of actual aluminum for around $30 a pair. That coupon can also be used on their laser cutting and CNC services. Be quick though, because there are only a few uses left for a limited number of our fans. Link is in the description. To mount our new auto refill fleet, I fired up FreeCAD and designed this custom triple bracket for the 3 Panda bamboo feeders. They use the same 2 screw holes as my previous single mount, with an optional 3rd hole on the other side for extra stability. I even included hidden cable channels on the back for the power extension wires that came in the expansion kits. It uses the exact same satisfying sliding dovetail design as before. Now these Panda feeders can heat up to over 60 degrees Celsius during long prints. On hot summer days, that is dangerously close to the glass transition temperature of even PETG, so we needed something stronger. We are printing this bracket out of gerGO ASA, who kindly sponsored the filament for this project. But to print ASA successfully on the massive SV08 Max, we needed to prepare. You can see I now added the insulation to the side panels of the printer using double-sided tape and frame clamping. On the back panel, I carefully cut out the areas for the fans and the thermistor, securing those inner edges with heat-resistant tape. And here is fail number 1. I initially cut the mylar insulation just a bit too small, and the double-sided tape by itself did not hold it well at all. I had to rip it off and completely redo it, clamping the edges between the side panels and the frame. We make mistakes, so you don't have to. Earlier, we lifted the heavy Max onto some furniture transport wheels, so I could now roll it right near the window, attach a venting hose to the upper exhaust fan this time, which Clipper calls fan 2, and physically blocked the airflow and unplugged the lower intake fan, because it kept turning on. Time to load up the gerGO ASA from our Sunlu SP2 dryer, set to a toasty 70 degrees. And cue fail number 2. The Sunlu suddenly threw an ERR2 code. I looked it up in the manual and it meant heating fan malfunction. Sounds scary, but I lifted the box off the heater and spotted a tiny rogue piece of filament that had fallen right into the fan blades. Quick fix, thankfully, because I really like using the SP2 for its incredibly low resistance on the spool roller bar. I preheated the printer to a conservative 50 degrees Celsius chamber temp first in less than 10 minutes, utilizing the 100-degree bed and our custom eye heaters. The heat camera showed very little heat escaping from our newly insulated side panels. I created an ASA profile in Orca Slicer with a 15% exhaust fan speed, triggered via filament start G code, and an NG code to turn it back off. When the chamber hit 50 degrees, I started the print. Which brings us to fail number 3. All went beautifully for the first 20% or so. Then the pieces started to warp and lift off the bed, one after the other. For the second attempt, I made 3 crucial changes. First, I sprayed the bed with a liquid glue from AliExpress. They are sponsoring this segment, and I'm actually planning to do a full bed glue comparison video soon, but this convenient spray glue worked wonders here. Second, I increased the chamber temperature to 55 degrees. I'm still a bit wary of going any higher because of potential tool head overheating and heat creep, but we will get to 60 eventually. Third, and most importantly, I realized that during our first quick preheat, the bed didn't have time to properly heat, so by the time the bed reached 100 degrees, the chamber was already at 50. So Damon Clipper Essentials skipped its adaptive heat soaking routine. This second time, the bed had plenty of time to take up its final shape before mashing, because it was already heated to 100 degrees from the first attempt, and I simply didn't let it cool down before restarting the print. So the mash turned out perfectly accurate, giving us excellent squish on the first layer. This print went flawlessly. A single Panda fed the gerGO ASA without a hitch. The exhaust fan running at just 15% completely eliminated that nasty ASA smell, and the eye heaters had absolutely no trouble holding that 55-degree chamber, only occasionally sipping 5 to 10% power. The heat camera showed the side panel staying cool at 35 degrees, with only the front and top glass panels rising over 40 degrees. The print finished beautifully, but then came the hardest part, waiting. To prevent heat shock and cracking, we had to let it cool slowly. Because of our improved insulation, This took a full 3 hours for the bed and chamber to reach room temperature. Time for assembly, and you guessed it, fail number 4. Because of material shrinkage, the sliding parts had a very tight fit. I did anticipate shrinkage and scaled up the model by 0.5% in the slicer compared to my PLA prototypes, but it seems ASA shrinks even more than I thought. I highly recommend printing these parts at 101% scale or even higher. Still, I managed to file the pieces down so they fit okay. I threaded the power extension cables through the channels on the back. The triple bracket uses the same 2 original screw holes of the Sovol feeder on the left of this bracket, and the ASA part should have plenty of strength to hold that long lever arm, but I've added a 3rd screw point just in case. You can drill a hole on your side panel or do what I did and use the double-sided tape pads included with the Pandas. I screwed the Pandas into the sliders, plugged everything in, and the CAN bus provided plenty of power to drive all 3 feeders, since only one actively uses its motor at any given time. Someone suggested leaving more space between the feeders, but that increases the lever arm even more. This layout works great for me, but I've provided more space than double and triple variants in the CALS 3D project anyway. Finally, we connected the runout sensor to the first extruder and hooked up the PTFE tubes to inputs 2, 3, and 4 of the filament hub. Now for the software setup. Connect all 3 units to your Wi-Fi as we showed in our previous video, making sure to assign static IP addresses in your router. Set their operation mode to Clipper, but only bind the first one to the max. And here's fail number 5. The official wiki tells us to long press the load button to set up leader and follower modes. Wrong. Long pressing load just brings up the self-test menu we showed last time. You actually need to long press retract on each unit. Select leader on the first one and follower on the other 2. Then long pressing load on the followers will bring up the bind prompt on the leader, where you simply press load for yes. A little confusing, but you'll get it. Notice the numbers 0 for the leader and 1 and 2 for the followers in the upper left of the mini screens. You can still go into the web interface of each unit to control things like their annoying beep sound, which I turned off to save my sanity with all 3 beeping at the same time. But the tension for all 3 is now controlled from the web interface of the leader only. By binding the followers to the leader, we basically created a mini Skynet. This Sovol Max is now fully self-aware and feeding itself. Hopefully it sticks to just 3D printing. If finding out the official wiki was wrong just save you a headache, please hit that like button and subscribe so we can keep making these mistakes for you. Levi tells me to ask you to hype us as well. You can only do it in the first week after premiere. Thank you for all your support. Now, how does this system actually work? The operation is surprisingly simple. When you push the filament into the leader, it acts just like before. It feeds it all the way to the tool head and triggers the load macro. But you also need to prepare one or both of the followers. When you introduce the end of the filament to their intakes, they will grab onto it but won't pull it any further. Their screens will happily display waiting. Only when the first spool completely runs out, clearing the sensor at the top of the hub, will the leader activate the first follower that is in this ready state. Which leads to fail number 6. Out of habit, do not cut the end of your follower filament to a 45-degree angle. You want a flat, blunt cut. That new filament is going to physically push the end of the old filament along the tube, so we need maximum surface area. We definitely don't want the new filament trying to slide next to the old one, especially in these more spacious ID3OD4 filament tubes. And fail number 7 happened because I didn't fully understand that working mechanism yet. I managed to get the silk PLA I was using for testing completely stuck inside follower 1.
Shit.
When this happens, you absolutely cannot just pull it out. I had to disassemble the unit by removing the 4 screws, then remove the grub screw, pushing the tensioning arm. The friction had melted the silk PLA and formed a nasty blob right on the end. I used the hot air gun from my AliExpress soldering station at a low temperature to gently soften the end, and then I was able to push it out. Speaking of pushing things out, I now posted our new unified and much improved macros in our called 3D project. It works beautifully with both stock clipper and Demon clipper essentials, and it should load and unload PLA and PETG much more reliably now. During testing, I discovered a curious behavior though. To completely unload filament from one of the followers, I actually had to press the unload button on the leader. And it finally made sense why the automatic unload stops just before completely letting go of the filament. This leaves it in that exact ready state the followers need. For absolutely perfect timing, we would need two-way communication between the printer and the Panda feeder. I've already contacted BIQU and hopefully we'll be getting that documentation soon. Until then, you will have to press the button a second time halfway through unloading through that very long PTFE tube. Also, for higher temp filaments, you still need to manually preheat your nozzle before pressing the load or unload buttons of your Panda feeders. When feeding from the standard spool holder, a tension setting of 4 worked perfectly for me, thanks to my low friction ID3OD4 PTFE tube upgrade earlier. Users with stock tubing report needing to bump that tension all the way up to 8. When feeding from the dryer box, the extra drag meant I had to increase the tension to 6. For our final test, I'm printing the casing for the extruders filament maker machine we are building in collaboration with our friend Juma Pili. I had a fun idea, we'll see how it turns out. Start printing from this almost empty yellow spool of PETG, and when it runs out, let the printer automatically switch to Filamentry's world-famous red PETG that Levi actually spooled himself during our factory tour. This will give a really cool two-tone appearance to the machine. I loaded both into our Sovol SH3 dryer at 60 degrees so they don't absorb moisture from the humid summer air during this 12-hour print. I fed the yellow to the tool head and it loaded without a hitch. I introduced the red to the entry of follower 1 and it said waiting. Now you might hear the pandas getting a little restless during Demon Clipper Essentials long preprint preparations. The easy fix? Lower all the nozzle preheat temps in your user settings to 169 degrees. The hard trigger for these feeders is exactly 170 degrees, so staying 1 degree below keeps them perfectly quiet. And if your PID tuning overshoots to 170 for a split second, don't worry about it. With that sorted, the print began, which brings us to fail number 8. Everything went flawlessly until the actual filament handover. The switch started okay, but follower 1 just kept screaming during the handover, struggling to keep up with the tail end of the yellow filament. No matter how I adjusted the tension, the added friction from the filament dryer combined with the heat softened material meant the gears of the Panda just slipped. It actually missed the handover entirely. and I ended up with a big gap in the first layer of the bottom piece. It goes on the inside, so I might not even need to reprint, but the feeding issue kept happening. I had to cut the filament, move the red spool out of the dryer and onto the regular spool holder, and prep follower 2. When follower 1 finally ran out, the handover to follower 2 happened beautifully. A clean switch with absolutely zero feeding issues. While it's not ideal to have the filament out in the open air, I could probably go back to using the more frictionless crossbar spool holder in the Sunlu dryer for these tricky handovers. So, lots of lessons learned today. The Panda feeders are incredibly strong and easily replace the stock Sovol feeder with a quieter, much more reliable system, but they do have their physical limits. You still need to reduce friction in the filament path both before and after the feeder. But if you do, you reap the massive benefit of fully automatic refill functionality for the absolute biggest prints this SV08 Max is capable of. If you haven't already, please use our affiliate links to get the BIQU feeders, the gerGO filament and all Sovol gear at the best prices while supporting our channel. Join our most dedicated supporters on ko-fi.com for all the behind-the-scenes scoops and discussions, and make sure to stay subscribed so you don't miss my hilarious, unavoidable but highly educational mistakes while building that extruder, the upcoming unboxing of Sovol's multi-tool wonder, the M1D, and so much more. Until then, watch our initial setup of the Panda feeders in this video right here, and catch up on all our previous adventures with our Sovol printers in this playlist. But most of all, go print 3D. Thank you for watching yet another gerGO Print 3D video all the way through.
I'll be back.